now we will discuss about duct heater, okay, and we will see that where duct heater is required, why it is required, okay, and how to do the sizing. Clear, right? Okay. Now, if you
Yes.
see one of the basic fundamental, ashtray fundamental, okay, where you can see there is a airflow path, okay, where maybe you can consider like ducting, okay, where you have a temperature like the condition of air at 1.1 and there is a different condition at point 2, right?
Yes. Yes.
Okay, now you can see basically you can see the cooling and you can see the heating, right? If you see the psychometric chart, okay, when you reduce the temperature, it is called the cooling. When you increase the temperature, it is called heating. Basically, it is like a sensible load, right?
Sensible load. Yeah. Yes.
Okay, so this is what you can see in this ashtray. So you can see the formula basically Q equal to M in the slash H2 minus H1, right? Okay,
Yeah.
so this is for simple heating or cooling. Okay, we will talk about heating with humidification in later section. Okay, but we will talk
Okay.
about now only the duct heater. Okay, where the duct heater will be
Okay.
used. Okay, so if I go to one
Okay.
of the picture, okay, remember we have seen fresh air calculations, right? Say for example,
Yes.
if I go to this particular AHU, okay, assume
Uh-huh.
that I have outdoor condition and I will be having a cooling coil, then I will be having a low coil temperature, right?
Yeah. Yeah.
Okay. Now, say for example, outside temperature is how much? 46.1, and say for example, 30 degree Celsius wet bulb temperature, where I'm going to cool it at low temperature, right?
Yes. Yes.
Okay. Now, I don't want this temperature to be supplied inside my space. Okay. I want, say for example, 25 degree, or I want, say for example, 22 degree, or I want 17 degree, right?
Okay. Okay.
Okay. Now, what is happening normally when you supply when the air pass through the coil? Okay, it will go to the it will go it, you will be cooling at low temperature, right? It will go
Yes.
to low temperature, which is like say for example 10 degree or 11 degree or 12 degree, something like that. Okay, but I don't want to
Yeah.
supply the same temperature into the space. I want to due
Okay.
to my this is not only for the normal application. Maybe you can say some of the laboratories, or assume that some of the chemical applications, okay, or maybe
Mm.
medical applications, or if say for example some of the oil industries, okay, where they want to maintain temperature. Okay, it cannot be cool or it cannot be at hot. Okay, you want to maintain
Mm.
certain temperature. Okay, in that purpose,
Yes.
what they will do? Okay, assume that you want to maintain, say for example, 12 degree from 12 degree to say for example 20 degree or 22 degree. Okay, you want to increase the temperature. So how you increase the
Yeah.
temperature? You need certain equipment, right?
Yes.
Okay, so to increase the temperature, you have a different type of equipments. Okay, either you can go with the heat recovery wheel, or you can go with the pre-cool or preheat pipe, right?
Okay.
Okay, or you can go with the heater is one of the option. Okay, where you can go with the heat recovery wheel, where you have a energy from which coming from the incoming, right,
Okay.
from the building, so that you can use the heat recovery wheel to heat the temperature.
Okay.
Okay, or you can
Mm.
use the pre-cool or preheat coil to increase the temperature. See what is happening here. Assume that this condition, okay, when you talk about fresh air handling unit, okay, say for example return temperature is 24 degrees Celsius, right?
Yes.
So this is the 24 degrees Celsius, and what is the temperature after the coil? Around 11 degree, 12 degree. Okay, so this energy, whatever the energy, will be transferred to this particular incoming supply temperature, right?
12 degree. Yes. Is
Yeah,
basically
12
converted
degree.
to
So
12.
you can
Yeah.
when the heat is transferred, there is a heating process is happening. You understand?
Yes. Yes. Yes.
Okay, so the temperature will be increased, right?
Yeah.
Okay, so this is one of the point which you have to note now. Okay, second one, okay, where I cannot use the sensible wheel, where I may use preheat or pre-cool pipe. Okay, where I can increase the temperature, right? For example, if you see the pre-cool and preheat pipe, what is happening? There is a refrigerant inside that will change there will be change in temperature. Here there will be cooling. Here there will be heating. Will be taken care, right?
Yes, but in this case here, irrespective of anything, you first have the energy recovery wheel is basically the heat recovery wheel that you're mentioning is basically the one which picks up both sensible and latent load, right? Or only the
No, this
latent
is
load?
one sensible and latent load. Yes,
Sensible and latent, right? Correct.
yeah, and this
Okay.
will be taken care only sensible load.
Okay.
Okay. Now where I'm coming, where you're going to use the duct heater. That is what we are discussing. Okay. So where and all you can
Understood.
use it, you use the duct heater when say for example, okay, I'm not, I don't want to use a sensible wheel. Okay. What you can use the
Okay.
duct heater here.
Okay.
Okay, there is a some say for example, assume that I have this condition, right? I have a condition 1, 2, 3, 4, 5, 6 degree, 6 conditions, right?
Okay.
Okay, when you see the condition 6, you are going to supply at, say for example, this condition number 4. Condition number 4 is what? 20.64, where the supply temperature is required, right? What is that? Is
Yes.
what my requirement, supplier condition requirement.
Yes.
Okay, assume that after the sensible wheel, okay, I'm not able to achieve 20.64. I can able to achieve only 16. So how you will
Okay.
increase the temperature? By adding the heater.
Okay. This is even after the sensible wheel as well.
Yeah, after the sensible wheel also, you cannot able to achieve the required supply condition.
Understood.
Okay, so this part of the, say for example, sometime you might have seen in FHU, they are using heat recovery wheel and sensible wheel and also heater, right?
Okay.
If you see your, when you're a consultant, if you see the equipment schedule
Yes.
when you prepare, you will say that you have to provide humidifier or heater to comply with the, what is the required space temperature.
Yes. Yes.
Okay, sometime you may have to add humidifier, sometime you may have to add heater.
Understood.
Clear, right?
Yeah. Yeah.
Okay, so this is one of the conditions where you will add the heater. Okay, another condition I will tell you that where we provide heater. Assume that there is a laboratory, okay, or there is some lab, okay,
Okay.
where you don't require condition. Okay, say for example, you have to maintain 30 degree or 35 degrees Celsius. Okay, in that
Okay.
spaces. Okay,
Hmm.
assume that you have a fan will be supplied normal ventilation to the laboratory, because you don't require any conditioned space. You don't require any treated fresh air or treated makeup air or something like that. Okay, you have to maintain normal temperature like 30 degree
Hmm.
or 35 degree. Okay, what will happen during the summer, during the winter? Okay, the temperature outside is very cold, right?
Yes.
So when the fan runs, it will take from air from outside, then it will supply the air at low temperature, right?
Uh-huh.
But this is a laboratory
Yes.
space. You cannot able to have a low temperature. You have to maintain normal temperature for the to maintain the room condition, right?
Yes. Yes.
Okay, so now to maintain this condition, okay, for during the winter, you cannot able to provide air at low temperature. So what
No.
you will do? You will add the duct heater, right?
Okay.
So these are the conditions. So you have to see that in which condition you will add the duct heater. That you have to find out.
Okay.
Okay,
Mm-hmm.
so this is one
But
of the condition.
generally,
Yeah,
but generally in the applications in the UAE, do you have? I mean, you have a duct heater. Well, not duct
uh,
heater. You need the heater or humidifier or whatever it
yeah,
is to ensure that you have the air is reaching the unit at 24 degrees Celsius.
yeah.
Fresh air. Yes, understood. But now, you said within the ductwork. You saying when the second option you said was having the duct heater within the ductwork itself, or
It can be, yes, it can be in the duct heater itself, sir. See, there are two type of duct heater available. Okay, one is like
okay,
inside the equipment. You can fix it on the equipment itself, because sometimes if you
okay,
see FHU comes with the heater or humidifier, right? Or AHU comes
okay,
with the heater or humidifier. So that is the equipment mounted duct heater. Okay, if you see there are duct heater which is duct mounted. Okay, say for example, if I see one of the picture, this is a duct mounted duct heater.
okay.
Clear, right?
Mm-hmm. Mm-hmm. Okay.
Okay, it will be
But
mounted directly.
then what is the advantage? Which one would you prefer if you are doing? You would still have prefer to have the heating option within the FHU and AHU, or would you
See,
prefer these
basically,
localized ones?
no, see, basically, first we have to find out. You can go with any of the type. Okay, say for example,
Okay,
the duct heater will be assume that the duct heater will be operated based on the cooling coil temperature or based on the equipment purpose. Then it is preferred with inside the equipment, right? In
yes,
you can have a common controller for the complete
yes,
equipment.
yes,
So
yes,
in that
yes,
case,
yes.
you can have a you can have an inbuilt heater. Okay,
Yeah, but
okay, so
this
that, yeah.
no,
So
no, please continue.
now we are going to find out why the duct heater is required first of all, and the second one, whether you will go with the duct heater, in duct like uh, like duct mounted or within the equipment. Okay, so that also you
Equipment
can decide.
mounted. Understood.
Okay, and why the duct heater is required, I told you. Okay, there are different temperatures. Okay, you have a condition 1 and condition 2 where where you want to increase the temperature, right?
Yes.
Okay, say for example, this is one of the case. Even though you provide sensible wheel, you cannot achieve the supply condition. So in that case, you have to provide duct heater to increase the temperature.
Yes.
Okay, because if you supply at low temperature, there is a chance of humidity. There is a chance of humidity inside. There is chance of moisture inside. So to avoid that, you are using a duct heater, right?
Yes.
Okay, so these are the purpose. Okay, now to calculate the duct heater, there is a simple formula. Okay, where you can go to one of the guideline which I am sharing with you. Okay, to calculate the duct heater required capacity. Is very simple formula. Same normal equation. Q equal to mcb delta T, right?
Yes.
Okay, the mass of the flow rate, the density of the flow rate and specific heat and the delta T. So this delta T will be, assume that I have this condition. Okay, assume that I have 16 degree, not 20 degree after the sensible wheel, right?
Okay. Yeah.
Now I want to achieve 20 degree. So what is the delta T? I have achieved
Sorry,
already
I think
16 degrees Celsius. What I'm saying, I
Yes.
have the fresh air handling unit, right? I have a heat
Yes.
recovery wheel, I have a cooling coil, I have a sensible wheel. Okay, I should
Yeah.
achieve 20 degrees Celsius. I should achieve 20 degrees Celsius. Okay, but
Yeah.
I can able to
Mhm.
achieve only 16 degrees Celsius because of the efficiency of the unit. Okay, I can able to achieve only 16 degree.
Yeah, that means
Okay,
before it reaches, okay, when you're saying after the sensible wheel means stage number 4, instead of 20, you're only achieving 16 degrees. So there's a
yes,
delta T of 4 degrees,
4 degrees
which
Celsius.
needs to be,
Yeah,
yes,
so that 4 degree you will able to heat that particular air, right?
heat.
So the delta T will
Yes,
be
yes.
16 minus 24, which is 4 degrees Celsius.
Is
Clear,
it
right?
16 minus 24 or 16 minus 20?
Yeah, it is actually 16 minus 20.
16 minus 20, it's not
Yeah,
24, right?
no, 16 minus 20 is 4 degree.
4. Oh, okay. Okay. Understood. Okay. Sorry,
Yeah,
my
yeah.
mistake. Okay. Fine. Okay.
Okay.
So you basically, okay, you're trying to find that difference at stage number 4, that is which is the delta T that you use. Okay, understood.
Yeah. So this is you can see the equation Q equal to mcb delta T, where the mass flow rate, then specific heat, and the delta T will be what is the condition you achieved and what is the condition you required. So that temperature is
Yeah.
the delta T.
Yeah.
Okay. Assume that if you have a different condition, this condition, okay, where you don't have a sensible wheel, okay, where you have this conditions, this condition, okay, you have a condition 1, condition 2, where you have a 12.78, okay, and where you want to increase the temperature to 24 degrees Celsius. So if you use the heater, your delta T will be like 12 to 24, right?
12.78, your delta T would be 12.78 minus 24. So that
Yeah,
is
24. So
around
that is
12
the delta T.
degrees.
Yeah,
Yeah.
so your heater size will be increased, right?
Yes.
So this is simple equation, but I'm telling you where the duct heater will be used. So if you go through this guideline, right? I have attached. I will be sharing you this guideline duct heater. Okay, what is the duct heater? Duct heater or electric heating element is installed in HVAC duct to provide additional heat to their as for passing through them, right?
Yeah.
They are essential. They are essential to any HVAC system as they help maintain consistent temperature and prevent condensation built up in the duct. Okay, that is what we are increasing the temperature. If you supply at low temperature, there is a chance of condensation, humidity. Okay,
Yes. So
clear, right?
that means
See,
in our, pardon, just to confirm, so that means in our FHUs when we do it, so for example, in the UAE, the dedicated
okay,
download system,
yeah,
you would have, typically, I'm just saying, I know as per the code requirement, we have to use heat recovery wheels for sustainability. I mean, yeah, for energy conservation, right?
yeah, energy
As per
conservation, yeah, yeah.
yes. So, for example, in our, so that means so in the projects in the UAE that you have done, have you actually used a heater where you have to bring the fresh air from, after the sensible wheel to 24 degrees or directly, or how have
No,
you done
no,
that?
no.
Because,
First preference is a heat wheel.
okay,
Okay, because when you cannot achieve in the heat wheel, only you will use the duct heater. Otherwise, your electrical power consumption will be very high.
very high. Okay.
Okay, first preference always first preference will be double wheel heat wheel. Okay,
Okay.
double heat wheel.
Yeah.
Clear,
That
right?
means where you
So
have the enthalpy heat wheel as well as the sensible one as well.
yeah, sensible one. Yeah, even if you cannot achieve in the sensible, then you can use the heater. You are allowed to use the heater.
Okay.
after the
Mhm.
sensible wheel.
So that still is something that you have to discuss with your manufacturers and select with your manufacturer selections and try to
No,
make a balance where it could sort of excel,
yeah,
right?
yeah. See, normally what option we will propose? We will propose with a double heat wheel. Then we will propose one with preheat and pre-cool and preheat coil,
Okay.
horseshoe pipe. Okay. Then another one option with duct heater. We will see that whichever is very lesser power. Okay. But ultimately the double heat wheel will be the lesser power. Okay.
Okay. Okay.
Okay. But where you cannot able to achieve the condition, then you will go with the pre-cool or preheat pipe. Okay. And you will
Yeah.
go with the duct heater as a third option. So you will go with the first option, double wheel. Then you will go with the second option, preheat or pre-cool. Then third option will be duct heater.
Duct heater.
Okay. Sometimes you will have a combination of all.
Okay.
Okay.
So
To achieve the
can you go
condition.
back to that pre-cool cooling coil and that? Yeah.
Yeah. This one.
Yeah. So basically over here in condition one, 46 air comes in. It reaches the enthalpy by each heat recovery wheel, which picks in the latent load and sensible load. And then after that, it further cools down. Okay, so this is where the refrigerant line. So this is where like the refrigerant line you mentioned, right? For the both pre and post, you will have a refrigerant line
Refrigerant.
which will work
Yeah.
on the opposite way.
Yeah.
Okay.
Yeah.
So
Which will
but
he? Yeah.
yeah, but this won't work in a chill water application though, right?
No, no, this is chilled water application only. What I'm saying, this is the preheat and pre-cool is one of the equipment. It's like a horseshoe. Like
Okay.
you might have seen this particular in the picture, pre-cool and
I
preheat. It is like this is a cooling coil. Okay. Remember
okay.
there is a
Yes.
horseshoe. How it will be like this, right? Okay. This is a separate
Okay.
equipment. This is separate equipment. What will happen? There is a refrigerant will be flowing through both direction. Will be flowing through both
Okay.
direction. Okay. So when it flows through both direction depends upon the type of temperature. See that
Yeah.
when it is cool, it will be transferred to here. When
Okay.
it hot, it will be transferred to here. Depends upon the density of the refrigerant.
Okay. 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 So
So
so if this is happening in chill water application also, you would still have the
yeah, still
refrigerant.
have this still have the refrigerant. Yes, yes.
Ah.
This refrigerant,
Okay.
yeah, this is one of the equipment. You can say heat recovery wheel is one of the equipment, right? Similarly,
Mm-hmm.
this is one of the equipment where you will be installing between the coils. So it's like a horseshoe pipe.
Yeah, can you show it to me like as an image? Like I mean, I know this is right now more like symbolism, but then do you have like an image that could show
Yeah,
that particular?
let me open one of the image.
Yeah.
Uh, you can see this picture here.
Yes.
Okay, if you want to see the actual picture, you can see this picture. Uh, you can see now enlarged view
Yeah. Yeah.
where you can
Okay.
see the refrigerant pipes.
Okay. 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 So you will have a separate outdoor unit just for these two items as well,
Yeah,
I guess,
no, this is
right?
not outdoor. This is one small equipment only.
No, no. I
Small.
mean, what I mean to say is that refrigerant means it needs to have an outdoor as well to expel the
No,
heat,
no,
right?
this is not required. This is not required.
Ah,
This is
okay.
only to
Mm.
change the temperature, only for sensible cooling and heating.
Okay. 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 Okay.
See, you have like see, assume that you have one side is the outdoor and one side is the indoor, something like that.
Yeah. Ah. Okay. Okay. Now I understood. I
Because
understood. Now I
the
think I
cool
got it.
the
Yes. Yes.
cold
Yes.
air
Yes.
will be
Yes.
transferred here because of the orientation. Can you see the orientation here? It is like a
Yeah.
inclined portion, right? So that the
Inclined.
hot air,
Yes. Yes.
the hot will be on the top and bottom will be on
Yeah.
the cold.
Cold side. Yes. Yes.
So it will be transferred here between that.
Okay.
Understand,
Okay.
right?
Okay. 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 Yeah. Yeah. Now I've got it.
Oh,
Yes. Yes.
okay.
Yes.
Now to
Okay.
calculate the duct heater capacity is just a simple formula where you will use. See, this is one of the Netronic duct heating element. Okay, where they use the calculate the kilowatt. Okay, duct heater capacity just by using that formula. CFM multiplied by temperature difference multiplied by 1.08 divided by 3413 for the imperial, and for metric this is the temperature.
Okay. Okay.
Okay, I will be sharing this information as
But
well.
this 3600.
No, this is just conversion. You can go with any of
Okay,
the,
it is a meter cube. Okay, you've
yeah,
converted
it
that
is
to
just
meters per
convert.
second, right? Okay.
Yeah, it is, you can say simple formula for sensible. You can go with this 1.08 multiplied by CFM multiplied by delta T, right?
Okay. Yeah.
You are clear, right?
Can you go back to the duct heater document that you have? No, not that one. Yeah, that one. No, not
Yeah,
that. Where we had all the cooling coils. Sorry, the different FAQ options that you had
yeah,
shown.
this option.
Yeah. So basically, yeah. So this pre-cool is in this. So this will have to go together. Both pre-cool and post-heat should go together. That is how this works, right?
Yeah, yes,
This
yes,
entire
yes.
structure. Okay.
Yeah,
So that means basically what we are trying to do is from the heat recovery wheel, when it reaches the pre-cool, it further cools the air to I think in stage 3 it becomes a 22, and then from
yeah,
22 it further drops down to cooling
yeah. 28 become
12.78.
24.57. Then after that,
Yeah,
coil 12.78. Then after that, you are heating.
yeah,
Okay.
okay, okay.
When you heat, condition C, condition 17.05, right?
Yeah, yeah,
Okay. So this is the post heat air conditioning. Assume that you want to heat, you are 17, you want 20 degrees Celsius,
yeah.
but you can able to achieve only 17.05. So what you will do,
Then you will add
you will do
another
the heater.
heater, right?
Heater, yes, yes, yes.
Mm.
Okay.
Okay, okay, okay.
Sometime you will see that option. Okay. By using the sensible heat wheel, you can able to achieve 20 degree. Okay. But by using the horseshoe pipe, you cannot able to achieve 20 degree. You can able to achieve only 17 degree. Then what you will do, you will obsolete this option.
Okay, this option won't work, and you will actually add the sensible heat recovery wheel, correct?
Yeah, sensible heat recovery wheel. Okay. Even though I cannot
Okay.
able to achieve by means of sensible recovery wheel, I cannot able to achieve by means of preheat, pre-cool or heat pipe, then you can add the duct heater after the sensible wheel, so that your heater will
Yeah,
have a lesser capacity, right?
lesser capacity. Yes, yes. Which you might require 5 kilowatts will reduce to 3 kilowatts or 2 kilowatts if needed,
Yeah,
based
yeah,
on the
yeah,
calculation.
yeah. Calculation, yes.
Okay, okay. So, but now my question here is, so for example, at the end of the day, when it leaves, okay, the air when it leaves the blower from the fan, it should be at 24, right? Typically, from a residential point of view, if you're saying for a residential application, we would always have the fresh air reach. By the time it reaches the equipment, it should be at 24 degrees
Yeah,
Celsius, 24 degrees C, right?
close to return temperature. Close to return temperature.
Close to the, okay, that's the term that we have to always use, right?
Yeah,
Closer to the
yeah.
return temperature.
Temperature,
Okay.
yes. Okay, why you supply less than return temperature? Because what will happen? There is a long ducting, right? Okay, so there will be chance of plus or minus one
Two.
or 2 degree increase in temperature. So
Hmm,
that is why
hmm.
you supply it like if you want 24, you supply 21 or 22.
Okay, 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 okay. Yeah, I
Okay, because
always
of that
put in that plus or minus two
yeah,
factor,
because
right?
of that long
But
run,
then,
because of
yeah, but
yeah,
the thing, but okay, I understand where you're coming from because most of our equipment would either be in a roof or in one corner of the entire floor, and from there you're traveling. So that is the factor that you're considering for the plus or minus two, correct?
yeah, plus or minus 2.
Okay, understood.
Okay, now you understand where we are using the duct heater and why it is
Yeah,
required, what is the
yeah.
purpose, everything, right? And how to calculate the duct heater. This is very simple equation, but to understand where we are using that we have to, because normally you don't prefer duct heater, okay? Because it is increasing. It's the capacity of the duct heater is
Electrical load.
very high, right?
Oh.
You don't propose duct heater most of the time, but where it is required, in which condition is required, only you will propose. Okay, sometime what will happen, you will on and off. Duct heater will say, for example, if you are using computer room air conditioning equipment, okay, where your
Yeah.
humidity is very important, okay. So
Hmm.
if the moisture is increased, then you will use duct heater to reduce the moisture. Okay,
Okay.
so there it is required, but duct heater will not be frequently used. Okay, only it will used when it is
Hmm.
required. Then it will have a cutoff.
Okay. So that means that particular electric heater will be connected to the BMS, and depending on the BMS,
Yeah,
it will
BMS
be
it will
controlled.
have a temperature. When it reaches the temperature less than the required
Yeah.
temperature, then the duct heater will switch on. When it achieves the
Okay.
temperature, then the duct heater will be off.
Hmm.
Clear, right?
Understood. I think I understood. Yes.
Yeah,
Yes.
yeah, yeah, yeah.